One protocol is not enough to make networking work. So there are so many protocols to divide the huge amount of work associated with exchanging messages, one of the main missions of networking. And these protocols are classified based on their roles or what they're doing. So some of the protocols belong to the classification application layer, others belong to the transport layer. Network layer has its own protocols, data link layer has its protocols, and finally physical layer has protocols associated with it. So let's take a look at some roles associated with protocol types. For example, application layer has protocols responsible for generating the data and also consuming the data. So if you're on the sending side, of course, generation of the data is your responsibility, but on the other side, when you're receiving the data, the consumption of the data is your responsibility. The network layer has a responsibility of delivering packets from one network to the other. So we're talking about sending packets from one local network and sending it outside the local network and then sending it to the other network outside the current network the host sending the packets belongs to. And then the data link layer delivers packets within the same network. So there are a number of protocols somehow designed to help the delivery of packets within the same network. And the packets in this case is enclosed in a container called frame. And as you can see, both data link and the network layers, the protocols belonging to those two layers or the categorizations, the main responsibilities of the protocol have something to do with delivering a message from one host to the other, either in the context of the same network or in the context of delivering the message in between the multiple networks. And finally, the physical layer is responsible for, or the protocols belonging to the physical layer are responsible for turning frames into electronic signals, because at the end, what goes through the wires is the electronic signal. And then in this case, the physical layer also has protocols defining what those network interfaces are doing to send and receive the electronic signals. I intentionally skipped the discussion of the transport layer earlier because the transport layer is really the highlight of our discussion in this video. So the transport layer is responsible for, or the protocols belonging to the transport layer are responsible for error detection, first of all. So it is possible that you receive sometimes damaged packets. Somehow something happens while the packet is being delivered, and then sometimes the packets are missing. Other times the packets arrive in an out of order fashion. So in that case, you really have to rearrange the packets so that they get organized into the right order. And then once you detect these errors, now it's time for you to correct the errors. So that's why we need to worry about error correction. And most of times, error correction can only happen by resending the packet. So you repeat this process of checking the errors, and then if there is an error, you have to send a request to basically retransmit the damaged or missing packets so that you have another packet that has all the information correctly. So that's really the main responsibility of the transport layer. There are two transport layer protocol types. One is TCP and the other is UDP. TCP stands for Transmission Control Protocol, and it is connection oriented because the protocol does error detection and error correction, as we discussed earlier. And then to make a connection, they go through this process called three-way handshaking. And the transmission of packets only occur after this three-way handshaking, when or after the connection is formally or officially established. And the whole point of three-way handshaking is to keep track of any sort of errors, and if there is an error, ask for retransmissions. UDP stands for User Datagram Protocol, and it is connectionless because it doesn't do the error checking or error correction, and sometimes you don't need to do the error checking and error correction. This is one of the reasons why you have UDP instead of TCP, although TCP has its own purpose, as you saw. So here are some examples of the use of TCP and UDP protocols. TCP connection oriented, UDP connectionless, right? So in the case of TCP, the key is making sure there is no error in the messages. So for example, emails or web browsing, you need error-free content, right? So if there is an error, there is a problem. So in those applications, you definitely have to use TCP. For something like UDP, applications that are very time sensitive adopt the protocol or UDP. For example, VoIP or voice over IP or video streaming. So the common theme across these applications is the fact that if you, for example, have a missing packet or damaged packet, there is no time for you to somehow stop the transmission and go back and then somehow retransmit, because everything's happening real time. So for example, if you're having a call with your friend, and then if there is one voice packet missing, there's no way for you to stop your conversation and wait until the missing packet is retransmitted. So for real-time or time-sensitive applications, UDP is a better option. So you can see why you also need UDP instead of TCP.